Okay, and we are back. I hope everybody had a good break and got some visiting done while we're on that break. And we are in the final stretch now of the Ethanol Emerging Issues Forum 2021. I just want to again thank all of you who have been with us this past couple days. I think we've had some great speakers, and I think we're going to have a great speaker here as we finish up. As I mentioned before we went into the break, it is really my honor and pleasure to have Adil Alsiyabi with us today. As I mentioned, Adil is one of the engineers who was working on this E30 demonstration project. So I'm going to just do a real quick introduction of Adil, and then Adil, I'm going to hand it over to you and let you take it away. So Adil Alsiyabi is a PhD candidate in the Chemical and Biomolecular Engineering Department at the University of Nebraska-Lincoln. He has been one of the main researchers for the year-long E30 demonstration conducted by the university's engineering department, which showed that E30 is safe to use in non-flex fuel vehicles. So Adil, I'm going to keep the introduction very short, and because I want to get to what it is you have to show us today. So with that, I will hand it over to you.
Thank you, Roger. Thank you for inviting me to present in this forum. I've learned a lot from the other speakers. I'm just trying to share my screen. Is it visible? Is the PowerPoint visible?
Up this time, Adil. You are good to go. You might want to speak just a little bit louder. You're coming through a little soft.
All right. So yeah, thank you again for inviting me to present here. I think we started working on this demonstration in the summer of 2018, planning for it, and it's just been great seeing all the different teams come together and make this work, especially from like a logistics point of view, making sure that all the data has been collected. A lot of these cars were very far from Lincoln, and so that wasn't very easy. And the drivers as well, making sure that they're always keeping the track of their mileage and things like that. So I'd like to thank everybody that helped make this demonstration work. So what we were trying to investigate was basically the long-term adaptability and the economic feasibility of E30 consumption in non-flex fuel vehicles. And so we broke it down to 4 main objectives. The first objective was determining if non-flex fuel vehicles can adapt to using E30 and compare that to use of E15, as well as looking at other more inherent differences in performance and looking if there is actually any difference or not between engine performance in vehicles operating on E15 versus E30. And then looking at, from an economical point of view, is it feasible to use E30? And finally, the larger impact, environmental and impact on ethanol use of a statewide adoption of E30. And so in terms of our experimental design, we went with a really data-heavy method. We ended up gathering tens of millions of data points. And this was possible by new OBD trackers that allow recording of real-time data. So these trackers are just installed into vehicles, and they track a number of parameters. We ended up tracking 16 different parameters, and they record them every second. And so we ended up with millions of data points that we can then go back and analyze. And we also, for the economical analysis part, we gathered data from drivers regarding the mileage and the gas usage for E15 versus E30. And so as you can imagine, dealing with this much data, a lot of the analysis is just making sure that you have you're working with what's called clean data or non-noisy data, so that the results end up being meaningful, and you don't just end up with a blur. And then once the data was filtered, we can then conduct different analyses to achieve our objectives, and I'll talk about these analyses in a little bit. So I won't go into details about all the parameters that we're tracking, but just some of the ones to keep in mind. The ones that are relevant are things like long-term fuel trim, which is basically telling you if the vehicle is detecting that difference in air-to-fuel ratio. And then things like engine load, which we use as a proxy for looking at engine performance. And then the oxygen sensor readings, which indicated if the vehicles are actually able to maintain an ideal fuel-to-air ratio even after increasing the oxygen content because of using E30. And we also looked at things like coolant temperature as an indicator of engine temperature to make sure that there weren't any differences or due to changing the ethanol content. And this is a picture of the sample of driver logs. And so what we're looking for here is we're using this to calculate the average efficiency, fuel efficiency for the two different fuel types. And then doing the gathering data on the cost per mileage, we can then get a cost per mile for each different fuel type and compare them that way. So moving on to the data analysis methods, I'll just give a very brief overview of the three main methods that we used. So the data was broken down to two parts. So there are parameters that we expect to remain constant, things like, as I mentioned, the engine temperature, things like the amount of oxygen that's being emitted, or that's unburnt oxygen that the engine's control module is trying to keep at a constant rate. And so for those parameters, we want to make sure that the distribution between the two different fuel types remains the same. And that will give a good indication of the adaptability of the control module to correct for that higher ethanol or for the higher ethanol and oxygen content. And then we have parameters that are constantly changing, right? And so for those parameters, we wanted to use more complex correlation and classification methods that allow us to look at how patterns in vehicles operating on E15, whether they're similar or whether they're different from those operating on E30. And that would give us a more accurate indication of how performance is changing. And then for the economic analysis, as I mentioned, we can, based on the driver logs and based on the costs, the changing costs per gallons of the different fuel types, we can get an average cost per mile for the time period that the study was done over. So some information on the vehicles that were participating. We had a total of 49 different vehicles, 9 of which were from the Nebraska State Patrol. And as you can imagine, these vehicles were driven under quite harsh conditions and very extreme conditions. And they end up covering a lot of mileage, approximately more than 20,000 miles per year. And so we got a significant amount of data just from those 9 vehicles. And then from the Nebraska TSB, we had data from 40 different vehicles, a significant amount of data, around 450,000 miles driven, to a total of 640,000 miles approximately driven during this whole year period. And so with that data, we're able to do statistical analysis to measure the significance of differences in distribution, as I mentioned. And so what I'm showing in this slide are 2 of the main parameters that tell us if vehicles can adapt to that higher oxygen content. So on the left here in red is we can see that the vehicles actually do sense that there's a higher oxygen content, and that's what we expect to happen. And so that's why we see that this higher average in E30 fuel trim. But then what's more important is that based on those readings, the control modules, the engine control modules are able to maintain the oxygen amount being in the exhaust to the desired level. And so that's what's telling us that the vehicles can adapt to this higher oxygen content of E30. And then, as I mentioned, we also looked at coolant temperature. There isn't any research data that indicates that higher ethanol leads to an increased temperature, but we saw we read some articles that indicated that this might be possible, and so we wanted to make sure that that wasn't the case. And as you can see here, the distributions for the two different fuel types are very similar, and so we can conclude that it doesn't, based on the coolant temperature, that the engine temperature does not increase due to a higher ethanol content. And then after that, moving on to analyzing the more complex, data, that's the dynamic data. And the main question that we're trying to answer is, does the performance of non-flex fuel vehicles change when we operate on E30 as compared to E15? And so we broke this down to two main questions. First of all, can we use all of this data that we've gathered to train a model to predict performance? And in this case, we used load or volumetric efficiency as a proxy for that. Can we use this data to train a model that predicts performance accurately? And it turns out that we can, and we used different methods that I'm not going to go into here, but it turns out that we can predict performance to a high degree of accuracy. And so once we made sure that that was the case, the second and more important question was, say if we train the model on data from vehicles on operating on E15, and then we test that model on data from E30, how good is the performance of the model? Because what high performance would indicate, or a high accuracy would indicate, is that there isn't any significant difference in the performance when moving to E30. And that's exactly what this plot shows here. What this is comparing is basically the observed load, which is the proxy for performance, versus the predicted, which is predicted on the model trained on E15 data. And so the most important thing is this high correlation, which is basically saying that, yeah, we can accurately predict the behavior on E30 using data, or using a model that was trained by data from E15 vehicles. And so this is a very good indication that performance, based on this data that we have, does not vary between the two different fuel types. And we verified this using different methods. I'm just showing results from one method that we used, but we got similar results in all different methods that we used. And then moving on to the looking at fuel efficiencies, we know there was a very slight decrease in fuel efficiency, a lot lower than just around 0.6 miles per gallon, a lot lower than you'd expect from the energy content, because as you all know, because of that higher octane rating, is able to offset most of the difference in efficiency. And then when you combine that with the lower cost of E30, even during the course of this year, the prices or the cost per mile evens out. And the main takeaway from this is that for a price difference of more than 2.5%, E30 becomes the more economically viable fuel to use. And so moving on from there, we wanted to look at how the impact of this study would look like if it was extended to incorporating E30 into state fleets. And so we looked at ethanol consumption. And as you can see, just incorporating ethanol consumption into the entirety of the TSB, the Nebraska TSB and the state patrol fleets, we calculated approximately 66,000, just going from E15 to E30, you get an increase of around 66,000 gallons of ethanol being consumed every year. And this just skyrockets if you look at starting to incorporate this into just the general public. So this plot here shows the increase in ethanol consumption if 10% of the registered non-flex fuel vehicles move from E15 to E30. So around 19 or 18.5 million gallons per year more ethanol consumed if that occurs. And then from an environmental standpoint, this translates directly to decreased CO2 emissions. And so for the case of incorporating E30 into the TSB and state patrol fleets, we predicted a decrease of around 530 tons per year of CO2 emissions. And then again, this is magnified significantly if we go to, or if this is incorporated into the general public. So if 10% of the Nebraska registered non-flex fuel vehicles convert to E30 from E15, that translates to around 64,000 tons in CO2 emission reductions per year. And so you can see that the numbers start adding up very quickly if this goes to a statewide or a nationwide implementation. And so with all this analysis, the next question is, what can we do next? And some of the things that we're considering are, first of all, going to a longer term demonstration, making sure that these trends are constant, and looking at the how prices of both gasoline and ethanol change over a longer time period. And then also looking at different makes and models. So we had a total of 3 or 4 makes and models in this demonstration. And so does this trend, or do these trends hold if we go to different, for example, pickup trucks or something like that? And then the final thing that we realized was that we can get a more accurate, or we don't need as much assumptions if we go to using retail prices instead of using rack prices. And so if we were to do this next time, we would use retail prices for the economic analysis. But with that, I'd like to conclude this talk, and I'd be happy to answer any questions that you have.
Okay, well, thank you very much, Adil. Certainly do appreciate that. Thank you for taking your screen off of share. And I have put the word out to everybody to go ahead and submit your questions. And I do have one thing while we're waiting for some questions to come in, Adil, that I'd kind of like for you to discuss. What we released earlier this month, or the first of this month, or on, I guess it was March 8th, was the summary of this report. The full report is going to be released later on, but it's going through the peer review process. Would you explain to our audience today why that is so important?
Right. Well, one of the most important things to get any set of results to be accepted is for it to first be accepted by the scientific community and the reviewers that are usually working in this field. So for them to make sure that all the analysis that was done was non-biased, that it was make sure that the assumptions that we started with are reasonable and things like that. And so if it goes through the peer review process, then we can say that these aren't just our claims, these are actually, they have been checked by scientists.
Right, okay, and it's extremely important. And that was what we were hoping to do with this report. The other thing that we like to point out when we talk about this is, even though it was the Nebraska Ethanol Board who was kind of the driving force behind this, this is a project that's been done entirely by you, the engineers at the University of Nebraska. We have had no input on the data whatsoever on this, and that's the way that we want it to be, to make sure that the public knows that yes, it's an ethanol industry associated organization that has started this, but it is truly unbiased information.
And the other good thing about having it published is that people can then recreate for themselves the data and reanalyze it themselves. And so they can also, since we're dealing with high amounts of data, they can even find other interesting trends that we may have missed. So
perfect.
that's another thing.
Exactly. So, okay, we do have a couple of questions that have come in here. So, did any of the drivers report better or worse drivability, cold start, or other subjective observations regarding E30 versus E15?
So I had a chance to talk to a few of them, especially at State Patrol, and this was the assumption. This is what their first thoughts were, that they would get cold starts, or that especially since they need to drive at really high acceleration, that they would lose a little bit of performance. But the second time I went around, it was just a completely different attitude. They didn't notice any difference in performance. And so that was, I think, one of the major things that maybe I should have highlighted here, is that the drivers and people working on this, how their attitude and their view of this changed as the demonstration went along.
Basically, seeing is believing, isn't it?
Yeah.
So what would a phase 2 of the E30 demonstration study need to look like?
So what we're looking at, or what we're focusing on, is more coverage, making sure we get, especially, and this has been brought up, I think, before, since we have a high population of pickup drivers, we can go into trying more or different vehicle types. I think that would be the most important thing, and looking at just a longer range is always, gives higher confidence. Longer time period, more miles, it always gives a higher confidence in the results. Yeah.
Perfect. Okay, here's another one. Did you investigate the short or long-term effect on the gaskets, seals, and hoses that comprise the fuel system in a non-flex fuel vehicle with higher blends of alcohols?
We did not. No, there is some literature out there, and there have been some studies that looked at this. We decided to keep it focused on this aspect of high data analysis and things like that. But I think it might be worth, based on the statistical significance of the other studies, if we can perhaps collaborate with someone that does something like that, or if we can use their results to back up. But
I think you kind of hit the nail on the head. There's been all kinds of studies that have done over the years on the properties of ethanol and E30, the E30 blends, on what kind of problems that could cause on seals and that type of thing. And as we know, the automobiles are now produced with seals that can handle those types of blends of ethanol. So we didn't want to basically waste your time as engineers on redoing what's already been done. We wanted to look on just what it means to performance of that vehicle. So I think.
Right. And also, just to add one more point, in the full report, there is we go through quite a comprehensive literature review of what's been done there. So we focus on, and a lot of these things were lab scale or a little bit smaller in scale, but we went into material compatibility of different ethanol blends. So we did a quite extensive literature review. And so if people are interested, they can look at the full report to get more information on that. Yeah.
Right. And that full report will be ready to go later this summer. Is that correct?
Hopefully, yeah.
Yes. Okay. All right. Our next question. The test was conducted during a time of wildly changing prices. Saudi, Russia, tough man contest, COVID. And you mentioned using retail prices in later tests. Have you run the cost numbers unofficially? Have you run the cost numbers unofficially, of course, using current retail numbers?
No, we have not. As the question points out, you can't get an absolute number by looking at the retail prices because they change so much, or by the prices in general. And so that's why I highlighted that 0.25% difference, because that's what's constant, right? So it doesn't matter what the prices are, as long as the difference is 0.25%, then it becomes more economically viable to use E30. I think that's what's more important to focus on, because as you mentioned, if you're looking at just the actual prices, then that would just keep varying.
All right, well, Adil, we are out of time for today, but I want to thank you so much for coming on and sharing with our audience today the results of this important project that has been going on here in Nebraska. So thank you very much. Appreciate you being with us today.